this lesson, we're going to take a look at a special type of relation called a function. So, we've considered 6 ways in which the relation between two quantities can be represented. In words, as a mapping or arrow diagram, table of values, an equation, set of ordered pairs, or as a graph. In a relation, every element of the domain or input, which is typically represented by x, is related to element or elements of the range or output, typically represented by y. In this lesson, we're going to take a look at the type of relation called a function. So, when we're talking about a function, we're going to use this example, where we're going to have a domain of 1, 4, 9, and 16, and a range of 1, 2, 3, and 4. For the first part, we're going to say, all right, we're going to complete the arrow diagram is a multiple of. 1 is a multiple of 1, 4 is a multiple of 1, 2, and also 4. 9 is a multiple of 1 and 3. And 16 is a multiple of 1, 2, and 4. If I'm saying is the square of, well, 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, and 16 is the square of 4. If I'm listing them out in sets of ordered pairs, I have 1, 1, 4, 1, 4, 2, 4, 4, 9, 1, 9, 3, 16, 1, 16, 2, and 16, 4. In the second set, I just have 1, 1, 4, 2, 9, 3, and 16, and 4. Now we're going to plot them on the grid. So for the first one, I have 1, 1, 4, 1, 4, 2, 4, 4, 9, 1, 9, 3, 16, 1, 16, 2, and 16, 4. And for the range and domain for the second set, 1, 1, 4, 2, 9, 3, and 16, 4. So when we're talking about a function, a functional relation or function is a special type of relation in which each element in the domain is related to exactly one element in the range. Another way I could say that is every x value is connected to one y value. So if I know my x, from my x, I'm only going to have one y value attached. All right. In the exploration, one of the relations is a function, and the other relation is not a function. So how can we determine which relation is a function? By looking at the following. So first, I'm going to say that if I'm looking at an arrow diagram, it's true if only one arrow leaves every element of the domain. Which is to say that there's only one arrow coming out of every value listed on the left-hand side. If I'm looking at ordered pairs, if every x value is only listed once. So if I'm looking at ordered pairs, every single time I have the sets, if I look at the number on the left, if ever that number on the left repeats, it is not going to be a function. So all the x values have to be different. And if I'm looking at a graph, I'm going to say that if each point on the horizontal axis has only one point on the vertical axis. So if I take these 3 points, for the arrow diagram, if only one arrow leaves every element of the domain, if every x value is only listed once, or if each point on the horizontal has only one point on the vertical, well, when I take a look here, then I can see that this has multiple points coming out. It is not a function. I can see that the ordered pairs have a repetition of x. That's not a function. Or I can see that the value of 4 has multiple y values that are all attached. That is also not a function, which means that is a multiple of is not a function, is the square of. I only have one line coming out of all of them. I never repeat any values, and I never have points stacked on top of each other, so this one is a function. Alright, so for each of these graphs, we're going to state for each input, there's only one output. For each output, there's only one input, and is it a function? Well, for the first one, for each input, there's only one output. For every x value, there's only one y value. That is true. For every y value, there is only one x value. Well, if I had a y value of 1, I can see I have an x value here and an x value of here. That's not true. But it is still a function because all that matters is that every x value only has one y value. For graph B, every x value only has one y value. That's true. Every y value, if I'm looking horizontally, only has one x value. That's true. This one is also a function. For C, every x value only has one y value. Well, I can tell that's not true because those 2 points, if I have -1 for x, they stack on top of each other. This has to be false. Every y value only has one x value. Well, that's not true. Those are side by side. That is also false, which means that this one is not a function. And when I get to graph D, every x value only has one y value. Well, this point and this point are stacked on top of each other. That is false. Every y value has only one x value. Well, if I look horizontally, that is true. There are never 2 points that are beside each other. And is this a function? No, it is not, because this is what makes it important, whether the input has only one output, not the other way around. Alright, so from graph C, write 2 ordered pairs which show that the relation is not a function, and join these points. Well, these are the points that show that this is not a function, so I'm going to say that I have the point of -1 and 8, and I have the point of -1 and 2. And I can see right there is my repetition of the x values. For graph D, it wants us to do the same thing. Well, those are the points that I already picked, and I'm going to say that I have the point of 1 and 1, and I have the point of 1 and -1. And once again, there's my repetition to show that this is not going to work. For A and B, draw a series of vertical lines. Do any of these intersect at more than one point? I could draw vertical lines all the way through A vertical lines all the way through B, and no. They're never going to run through more than one point on the graph, which is why they're functions. We refer to this as the vertical line test. We're talking about the vertical line test. It means that if I draw a vertical line all the way through the grid, there is never going to be any 2 points that a vertical line will cross through. If it does cross through more than 1 point, it is not a function. So, if I'm determining whether or not these things are functions, well, take a look at example A. I have, for the domain values, 5, 6, -5, 2, and 6. I have two of the same. It is not a function. The 2 points are repeated. If I take a look at B, I have 3, 2, 4, and -3. This is a function because the points never actually repeat. For example C, I have one arrow coming out of A, one coming out of B, one coming out of C. It is a function because every point on the left side only has one arrow coming out of it. When I get to D, this is not a function because it fails the vertical line test. For example E, the relation connecting the points of provinces and territories of Canada with their capital cities, this is going to be a function. Why is that? Because every province has only one capital. When I get to F, this is going to be a function because it passes the vertical line test. At the same rate, when I get to G, this is not a function because it does not pass the vertical line test.